thank you once again, and let's go to the presentation by Yurij Krugly. Yuri, you are able to share the screen now, so please, the stage is yours.
I try to do it. Okay. Okay. Can you see my presentation now?
Yes, we can see your presentation.
Okay. Thank you.
But could you move closer to the microphone? We can hear you.
Okay, try closer to be.
Okay, now it's a bit better.
Okay, thank you. The presentation devoted our possibility to observe with equipment at our Chuguev Observatory in Ukraine. It's a map of Ukraine, and we located in the east from the Kiev, in the east of the Ukraine. You can see in right up corner, and it's our place, our telescope, 70-centimeter telescope, and it's characteristic of this system that we can use. We observe in Newtonian focus 2.8 meter with CCD camera, ML 4710, and now we have changed. We have another camera that we obtained from our government grant, and this camera under icon M9974, and also we have two sets of different filter sets, Bessel set and also Sloan filters. And this is camera obtained from grant of our National Research Foundation, and we hope that will give us more possibility to use our 70-centimeter telescope with good efficiency, spectral efficiency of this camera in wide spectral range. In all filters, we have very good signal we expected to have, and some characteristics of our place, our observatory, and we usually with our telescope obtain it photometric accuracy 0.03 magnitude better from this for the magnitude of 17, and we stay on sea level, and so the quality of our seeing is not very good, but in range from 2 to 5 arc seconds, and we have a limited magnitude up to 19.5, and about 100 nights per year we have. I also have to say that this telescope we used fully for photometric observation of asteroids. So it's our domestic telescope, and in frame of the EUROPLANET net in last year we have one project with Dagmara Oskrzewicz from Poland Observatory for observation of V-type asteroids outside the dynamical Vesta family, and during the allocated time for this project we have not weather in one night, and so we can obtain it two objects, two asteroids of Dagmara, in another our partner observatory in Abastamani, in Georgia. And so this is results obtained. We obtained two composed light curves, and for genes we expected to have phase relation dependencies. Another project that we included it's photometry in support of Gaia survey, and you know that Gaia observed asteroids with other objects during its survey, and so our photometry for asteroids, for in particular for Huberta asteroids, was close to the observation of Gaia observation of asteroids, and so you can see color points on the light curve. It's show it on one picture our photometry in dark, and in colors photometry with Gaia, and so good fit between them. And in below you can see the phase relation obtained from ground photometry, and green the red point showed the photometry with Gaia. Good fits also. What about the works that we do with our telescope, 70 telescope in Chuguev Observatory? It's absolute photometry of asteroids, different types, and it's monitoring of properties of near-Earth asteroids, and we can also observe space mission and radar targets, radar asteroids in support of that observation, and also try to use our telescope for stellar occultation, observation of stellar occultation by asteroids, and as well no objects. Some results for absolute photometry, it's it's like composite light curve from our observation, absolute calibrated data with good precision, and after this light curve we can obtain it such dependent phase angle dependencies, magnitude dependencies. And you can see in our main the aim of such observation close to the zero to it's give us to obtain it absolute magnitude with good precision. And another asteroid Abastamani observed in Kharkiv, and also in Chuguev Observatory, sorry. And for these asteroids, we obtained unusual phase relations, and its phase relations given us to say that Abastamani is not a bright object, but it's within it's a dark object, because only dark objects, mainly D-type asteroids, show it no opposition effect on this magnitude dependence. And so our magnitude dependencies measurements, many observation was used mainly to improve phase magnitude absolute magnitude system, and it's this is in right corner below image. You can see our database for magnitude phase relations. And so another object that we are interested and observe with our telescope for investigation physical properties is near-Earth object. It's some pictures that you know from different it's from space mission from radar observation, and our mainly tasks is to study the potentially hazardous asteroids, newly discovered, search binary asteroids, investigate such ungravitational at Europe, and also to support of space mission and radar targets. This is curves that show us about mainly about shapes of the asteroids. We take part in another network, ISON network, that mainly devoted to space debris observation, but also for asteroids and gamma ray bursts, afterglow observation. And more than 10 years, we cooperate with observatory that participate in this network. And as a result, we have more than 20 near asteroids investigated per year for observation of Lightcurve, mainly Lightcurve observation for asteroids. It's the map of that network, and in green color mentions the observatory involved in photometry. It's some list of the observatory. They do regular observation, photometric observation of asteroids, near-Earth asteroids mainly. And so this is another example of our work. It's binary asteroids that are interesting for us because they give us to understand the interior structure of this asteroids. Interesting results obtained in last time for asteroid 2000 VO 107, and this is data obtained for this asteroids in parallel for us observation with radar in Goldstone Observatory, and you can see that it's contact binary asteroids, and we used our photometric to estimate the density of the system. Sorry, this one is we obtained density about 1.6 gram on centimeter cube, and it's interesting because many other facts say about that its asteroid can be metallic nature, and this metals inside. But we try to understand the nature of metal asteroids, and in this slide, another observation. In left, there is a Lightcurve for asteroids, main belt asteroids Ingrid, and very big amplitude at small phase angle show at us that this unusual asteroids with some unusual interior properties rotates with period about 5 hours, and so we can suppose that it's maybe metallic asteroids, and also spectral observation of these asteroids also support this fact. And another one, asteroids on the right, you can see that have the unusual Lightcurve that also can see us about this binary structure, binary system, and very good cooperation between photometric and radar observers show it on this slide, because we can construct more precise shape of asteroids when we carried out observation in parallel in radar and optics. And two words about calibrated photometry with using the pipelines. We started to use pipeline photometry pipeline created by Michael Mommert, and it's our first results. And there are some problems with using this pipeline, but in some cases, in left you can see good Lightcurve for asteroids in rows, and you can see that in right slides it's not good data that depends on some properties of this pipeline, because this pipeline not oriented on moved object as are asteroids, especially near-Earth asteroids. So thank you for your attention. Maybe you have some questions. It's my colleagues, we are working with asteroids and comets physical properties. Thank you.
Thank you for your talk and for presenting your telescope and its possibilities. I'm sure that all of people that were presenting telescopes today will have many applicants and requests for observations. Do we have any questions to Yuri? Yeah, okay. Yeah, again, I'm impressed about the use of the combining the radar data with the light curves. I know that it's very difficult, but very powerful tool. So thanks for mentioning this. And thank you for all speakers today. We've got a very efficient day, I think, and very efficient the whole 3 days, the whole workshop. I think it is really nice that we could gather together the scientific topics and scientific presentations, and people showing capabilities of the telescopes. I think after this workshop, new collaborations will be started, and the people needing observations will be very happy that they can use new telescopes and new observing times. So I'm really happy that we could organize this workshop, and I think it will be fruitful for many of us. We are a bit out of time scheduled for the workshop, but the whole presentations were so interesting that I think the people who are willing to discuss something can stay longer and discuss what they are interested in. So thank you all of you for your attention and for this workshop.